Good morning, chemists. So we started talking earlier this week about acids and bases. You can see in this slide here, it's a review of what we've already talked about, some properties of acids, like they taste sour, react with metals, turn pH paper red. Bases, you see, are bitter, they feel slippery, turn pH paper blue. You guys can read that on your own, but what we're going to focus on today is this thing pH. And by the end of today, you should be able to calculate pH as well as pOH. So what are they? pH stands for power of hydrogen, and it's looking at how acidic a solution is. pOH, just the opposite, it's looking at how basic something is. Now here's the thing, these are both measured in powers of 10, so the lower the pH of something is, the more acidic it is. Same thing with pOH, the lower that is, the less basic it is. So when these are higher, they're the opposite. Okay, so just keep that in mind. So 7 would indicate a neutral solution. Things that have a pH of less than 7 are acids and greater than 7 are bases. Again, the lower that number, the more acidic something will be, and the higher that number, the more basic something will be. When you look at pOH, it's the opposite. The lower that number, the more basic it will be, and a higher pOH would indicate something's very acidic. Because if you guys see this second bullet point here, every decrease in 1 unit describes a solution that would be 10 times more acidic or basic. Okay, this is a logarithmic scale. You could see here some examples. So again, in the middle, 7 means neutral, and water is the example of a neutral solution. Some basic things you can see are stomach acid, lemons, grapes, things you think of that have an acidic taste, salsa, tomatoes. Where basic, you see a lot of cleaning products, soap, baking soda, ammonia, drain cleaner, all right? And then there's some great pictures here too. Notice on this diagram, the more acidic things are turning more red, where the basic things are turning more blue. And then in the middle there is that yellowish green color to show neutral things like water. So how do you calculate pH and pOH? You have all of these formulas on your reference sheet. If you can't find that, maybe take a screenshot here or go back to Google Classroom and make sure you bookmark that. But we're going to be using these formulas today. Okay? And just keep in mind two things here. pH and pOH do not have units. They're just numbers where, remember, those brackets mean concentration. So when you see concentration of hydrogen or concentration of hydroxide, it's going to be in molar. You also want to take into place, especially HP with your sig figs, pH and pOH will give 2 decimal places, where concentrations of hydrogen and hydroxide will be given in scientific notation with 1 decimal place. So again, you might want to star those, take a screenshot, but you want to keep those rules in mind when we go through. So what I'm going to do right now is I'm going to go through some practice problems with you. So here's one. It says calculate the pH if the concentration of hydrogen is 0.015 molar. So in this case, our given is the concentration of hydrogen and our unknown is pH. So remember, the formula for pH is the negative log of hydroxide. And please don't mind my penmanship. This is the first time I'm doing this, trying to figure out how to write with my finger here. All right, so again, if I want to plug in my given, I'll do the negative log and then my concentration of hydrogen. Okay. And now when I plug that in my calculator, I'm going to plug just like it looks. I'll do the negative, I'll hit the log key, and then I'll just put in 0.015. And if I do that, my answer is going to be 1.82. Okay, now notice I have 2 decimal places and no units. Your calculators probably said 1.823908, blah, 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 blah. But again, with pH and pOH, we always want 2 decimal places and there's no units. Okay, so that's how you get pH. Another problem might ask for hydrogen concentration. Okay, so this time we're looking for hydrogen concentration and it gives us pH, so just the opposite. When we're doing that, if we look at our equation to get hydrogen concentration, we're going to do the opposite of a log, which is raising something to the 10th power. Notice it's negative, okay? So when I plug it in my calculator, I'll put in 10, the exponent key, or you can hit the caret key depending on your calculator, a negative sign, and then the pH we were given was 11.22. If I do that, hit enter, you will get 6.0 times 10 to the negative 12th molar. Notice my answer is in scientific notation and 1 decimal place. Okay? This is normally the part where I'd ask you to, if you had any questions, or I'd have you guys do a problem, but clearly we're going digital right now. So if you did have a question, maybe pause this, see if you can catch me on my office hours, or shoot me an email. Let's look at it. So those two are looking at pH. Now let's look at pOH, which is very similar. So in this case, we're looking for pOH, and we were given the concentration of hydroxide. The only difference here, chemists, is instead of the concentration of hydrogen, we have hydroxide, because what makes them more basic is that hydroxide on them. So if I look at my formula, I have pOH equals the negative log of OH negative, the hydroxide. So I'm plugging it in just like before. I'll hit the negative key, the log key, and then I'll go ahead and put in my number, which in this case was 3.8 times 10. I'll hit the caret or the exponent key depending on my calculator, negative 4. And if I hit enter, I will get 3.42. Again, 2 decimal places, no units. Now let's look at a concentration of hydroxide problem, okay? Going the opposite way. So this time we were given the pOH, we want to find the hydroxide. To do that, we're going to use our formula we went over before. Concentration of hydroxide is equal to 10 raised to the negative pOH. Okay, so when I do that, from here it's just plug and chug. I put 10 in my calculator, hit the caret, either the caret or the exponent key depending on your calculator. Okay, negative 5.76. And if I do that and I hit equal, I will get 1.7 times 10 to the negative 6 molar. Now, keep in mind, this has to be in scientific notation. If your calculator is like mine, you got 0.00017, so on. Okay, but remember, whenever you're looking for concentration, it's going to be in scientific notation with 1 decimal place. Also, don't forget your units. Okay, one more. And this one actually is probably the easiest one. So remember I said on the scale you went from 1 to 14 were things that were lower or either more acidic or basic, and higher were less acidic or basic. Well, the cool thing about that is that because of that, we know that pH plus pOH equals 14.00, since we want to go to 2 decimal places. So in a problem like this where you're given pH, you just need to subtract to work backwards to get the pOH. Okay? So if we want to go ahead and manipulate our equation, it would be, we'd get pOH equals 14 minus the pH, which if we plug in our calculator would look like this, 14, hit the minus key, 12.50. Notice I'm still keeping my 2 decimal places, and in that case I would get 1.50. All right, 2 decimal places, no units. And that's how to calculate pH and pOH. Send me a message if you have any questions. Good job, chemists.